and welcome to Arithmetica, and a third video in our presentation of proof and reasoning. In the previous video in this series, we covered the topic of deductive logic. In this video, however, we introduce a different form of logical inference called induction. Later, after we provide the basic notion of inductive logic, we shall then provide a couple of examples in the familiar syllogistic form as presented in the previous video covering deductive inference. So, following on from our previous video on deduction, we note that logic, however, is not restricted to the formal constraints of deductive logic and that of logical validity. There is also the branch of reasoning called inductive logic. Unlike deductive logic, inductive arguments are neither completely valid nor invalid. Instead, the strength of the argument following from its premises is better described in a continuum that lies strictly between complete logical validity and absolutely no logical validity. Logical induction, therefore, has a sort of graded quality as being weak or strong, depending on whether it is near logically invalid or near logically valid, respectively. Consequently, even with true premises in force, unlike deductive logic with its strict conditions in allowing it to draw certainties in truth, induction allows for greater flexibility, but at the cost of drawing conclusions in probability. And so the main advantage with inductive logic is that it is better suited to problems in everyday situations, rather than in formal axiomatic systems such as mathematics and specific branches like set theory. Although one obvious downside is that without logical validity, it is entirely possible to derive false conclusions from true premises. It is the formality that mathematics is founded upon which allows us to reap the benefits of deductive logic in mathematical proofs, whereas science makes better use of inductive reasoning in providing a statistical quality supported by empirical evidence. Indeed, it should also be noted that there is another form of logic called abduction, in which the forming of scientific hypotheses has been greatly attributed to. But more on that in the next video. We begin with a simple example of induction. Suppose that you learn of some low pressure coming your way, or that from your own barometer there has been a sudden drop in atmospheric pressure. You remember from your science lessons from school that there is a strong correlation with low atmospheric pressure and rainfall. You infer that it will likely rain soon. Let us deconstruct the inference into syllogistic form and take the major premise to be low atmospheric pressure allows for the rising of water vapour where it can attain high enough altitudes to cool and condense into clouds of water droplets and ice crystals. Eventually, these clouds can become rain clouds, which are prone to rainfall. And the minor premise to be there is a sudden drop in atmospheric pressure. We may then inductively infer that, therefore, it seems likely that it will rain soon. Notice that we use the phrase "it seems likely" to ensure a correct inductive argument, rather than "is" or "must be." The distinction being that the former communicates in terms of probability, while the latter deals with certainty. Other suitable words would be could, maybe, or possibly. Of course, we cannot be certain that it will rain, or for that matter, how soon it will be until it is likely to rain. We would need to question the source of the data informing us of the apparent low pressure, as well as just how low the pressure has dropped. The major premise, as stated above, is perhaps phrased with more details than one would need for this particular inference. We would do just as well with stating the major premise thusly. There is a strong correlation with low atmospheric pressure and the potential for rainfall. For our second example, we shall provide a more detailed approach in considering the inner components of the inference. Suppose it is known that Tarzan is going to marry Jane. We also know that Tarzan has been seen with a beautiful red diamond ring. We could then induce that Tarzan is likely to wed Jane with that diamond ring. The logic could go something like this. Take the major premise to be, in marriage, it is often the case that the intended couple exchanges wedding rings during the wedding ceremony. And the minor premise to be, Tarzan is going to marry Jane. We may inductively infer that Tarzan will likely marry Jane with a wedding ring. Although it may turn out to be a false conclusion, if, say, neither Tarzan nor Jane intend on participating in a marriage ceremony that includes the exchanging of wedding rings. In any case, from this, we have the major premise as Tarzan will likely marry Jane with a wedding ring, and the minor premise as Tarzan has been seen with a beautiful red diamond ring. We may then inductively infer that Tarzan is likely to wed Jane with that diamond ring. Since this is an argument in inductive logic, we can only conclude a likelihood. Only deductions deals with certainties. From these premises, we can only consider the possibility of Tarzan wedding Jane with that particular diamond ring. It might be that he was seen on his way to returning it to its rightful owner, or was to replace it with a different ring for Jane. And so, without context, all we know is that Tarzan had in his possession a red diamond ring. What he intends on doing with it is a different matter entirely. Probably eat it in mistaking it for a very shiny red berry. There will be some distinctive ululation once that passes through, followed by another victory cry once completed. Let us just return to the premise concerning wedding ceremonies. Indeed, it might be that if one were to only experience weddings, which include the exchanging of wedding rings, then it would be reasonable to induce from this that it is possible that all marriage ceremonies include the exchanging of wedding rings. This highlights the property of induction in deriving a generalization from particular instances. In contrast, deductive logic usually derives a particular conclusion from something more general. As the evidence mounts up in supporting such observations, the more credible the conclusion is via induction. This also demonstrates the statistical relationship with inductive logic, since the more evidence there is, the greater the statistical viability of the conclusion. Of course, we need only one counterexample in order to disprove the conclusion, regardless of how many cases one has been made aware of in, say, the necessary exchanging of wedding rings. Another case to consider could be that of the premise all men are mortal. Now, I claimed in the previous video covering deduction that this was obviously true. But why the certainty? Well, it's again a matter of statistical certainty. not only are human beings known to medical science as mortal, we experience on a daily basis the news of people dying from old age, as well as being very much aware of the passing of members of our own family. Moreover, it is a simple matter of our biology and the need to procreate as an extension of our mortality for the survival of the species. But this is still a generalization from what we understand to be true. We have induced that all human beings are mortal, and therefore so must all men be mortal. However, an appropriate mutation in our DNA could perhaps genetically provide some form of immortality, but would otherwise appear completely human. Sounds like an X-Files? Or maybe X-Men? But let's be honest, not very likely, but perhaps not entirely impossible. That's it for this video. I hope that you enjoyed our introduction covering inductive logic. In the next video of Arithmetica's presentation in proof and reasoning, we will continue with 2 additional examples of induction. And so until next time, it's goodbye from Arithmetica.